In this demo of Gloo Platform Portal, we'll demonstrate a use case in which individual app dev teams are developing microservices as APIs, for example REST APIs, gRPC, GraphQL, etc., and deploying them to Kubernetes. These APIs can be bundled into API products, which can be exposed via Gloo Portal to other users and developers for consumption. APIs can be bundled into API products in multiple ways. There can be a one-on-one mapping between the API exposed by the service and the API exposed in the API product, but an API product can also be a composition of multiple APIs exposed as a single endpoint. The primitive we use to create an API product is called a route table. These route tables are then exposed to the outside world through a gateway or a virtual gateway. We use the concept of delegated route tables to expose a single host or domain for the API and use delegated routing to route to individual APIs under that domain. We can expose the developer portal on the same host as our APIs, but this can also be a different host. In this demo, the developer portal and API are exposed via different hosts. Developer.example.com for the developer portal and api.example.com for the APIs and API products. Our portal resource selects the route tables or API products to be added to the developer portal by labels. This forms the configuration that is exposed through our developer portal REST API. The front-end developer portal UI communicates with the developer portal via its REST API server. We provide the developer portal UI out of the box, but since our developer portal provides a RESTful API, different UIs can be integrated with Gloo Portal, for example a Backstage plugin. This creates a flexible model in which we can easily implement concepts like segmented internal and external developer portals, or maybe something like a partner developer portal. In these models, multiple portals can be deployed and mapped to different virtual gateways. This allows you to map different virtual gateways to different cloud provider load balancers to segment traffic and access. Another option would be to make both portals accessible via public endpoints and to use an OIDC provider to define different security policies for these different portals. There are many different options and combinations. In this demo, we will deploy the following architecture. This architecture shows several different microservices, APIs, gateways, and other components. We'll give a brief explanation. The black boxes at the bottom of the diagram represent microservices, so tracks, paths, users, and store microservices that expose a RESTful API and its microservice implementation. The track RT and path store RT represent Gloo route tables, and as stated earlier, are the primitives we use to create and expose API products. The portal defines the Gloo Portal, being the developer portal that hosts our API product definitions and in which we can apply API policies like security and rate limiting, and where API keys can be generated to grant access to our APIs. The api.example.com route table routes traffic from the api.example.com domain to our services. The developer.example.com route table routes traffic from the developer.example.com domain to the developer portal. And the virtual gateway exposes our routes to the outside world. Let's walk through our demo. In a clean Kubernetes environment, we have deployed Gloo Platform, including Gloo Portal, and we will now deploy a number of REST APIs, RESTful services, that we will expose as API products through our Gloo Portal to our consumers, which would be the developers. So let's first check that we don't have any services deployed in the default namespace apart from the Kubernetes service, and also let's check that we don't have any API docs deployed in our cluster. So there's nothing here, it's clean. Now we're first going to create a namespace for our tracks microservices. So we create a namespace tracks in which we can now deploy the tracks API. So -f apply -f APIs tracks API. So we deploy the service. So let's take a look at that YAML file that we're deploying here. So we're going to have a look into Visual Studio Code, and there's basically a deployment and a service. As we have seen here, there's a deployment and the service that have been created. And there's one annotation that we need to take a look at, which is the Gloo scrape open API source. So this basically states that within the service we want from this path, we want to scrape the OpenAPI source for this service. And from this OpenAPI source, the platform will automatically create an API doc. So let's see if that has already happened. And we can indeed see that there is now a tracks API doc. We can, in the tracks namespace, so we can take a look at the content. And we can see that here we have the Swagger or OpenAPI specification of our service that was scraped from the Swagger JSON that we have defined here as an annotation. So this API doc is automatically created. This API doc defines both the API definition and the destination that serves that API based on the cluster and the namespace, name, selectors, and the port. So now that we have the API deployed, we can expose it to the outside world, and this is done by creating a route table. So the tracks API RT YAML file contains the definition of the route table that exposes the tracks API. So let's take a look at that file. So the tracks API RT file is here. And what we see is the portal metadata field in the route table resource, which allows us to specify additional metadata about our API. So the metadata is then provided via the Gloo Portal REST API, and from there you can be exposed to the developer portal UI. So it is a way for us to add additional metadata to the API and to the API product. And this metadata can include fields like licenses and titles, descriptions, service owners, data classifications, etc. Now that additional metadata will be in line with the service's Swagger API definition. But apart from that portal metadata field, this is a standard Gloo Gateway route table resource that defines the routing rules. And note also that routes can have labels. And this mechanism is used to wire in various policies. For example, the Tracks API route is the label usage plans dev portal. And this usage plan is defined, for example, in the Excel policy, which is shown here. Let's see, the auth policy, here we go. So this is the Excel policy. And we can see that this policy needs to apply to all routes that have the label usage plans dev portal, which is exactly the route or the label that's defined on a route here that exposes our tracks API. So let's now apply the route table resource, and we're going back to the command line, and we're going to say k apply -f tracks API route table YAML. And if all's well, we can now see the API in the Gloo Platform UI that we've already opened in the browser. So here is the Gloo Platform UI. And if we go to APIs, we can see that Tracks API being deployed here in our Gloo Platform environment. We can see the API schema as well, the OpenAPI definition, including the operations and so forth. Now, the final thing that we need to do to expose our API to the outside world is to connect it to the top level domain. Now, this can be done with labels and selectors, but in this demo we use a static configuration. The api.example.com RT YAML file defines the route table resource that exposes the APIs on api.example.com. So let's take a look there. So here's the api.example.com route table YAML file. So let's open that. And this route table file exposes the tracks route table via the api.example.com hostname. Any request that comes in that has a prefix of /track API is delegated to the tracks route table that we've seen earlier, which basically defines our API product. So let's apply this route table as well. So we do a k apply this f API dot example dash example.com route table. So we've now created the route table that delegates to our tracks API route table, and we should now be able to curl to that endpoint. So note that you might need to edit the etc host file to map api.example.com domain to the IP address of your Kubernetes cluster, but we've already done this in this environment. So we can now do a curl-v api.example.com track API tracks. And when we run that, we can see that we get a nice RESTful response back from our tracks API microservice. Now let's add some security to the mix. We've already briefly looked at the auth policy, which is defined here in the policies directory. And we can see that that applies to all the routes that have a usage plan dev portal. And what it does, it has a configuration where it says that we need an API key authorization here. So there needs to be a header in our request with the name API key, which needs to have a valid API key to be able to access our service. So let's apply that security policy, and we do that again, k apply and -f policy, and we use the auth policy. So that policy has been created, and if everything is correct, when we now curl our tracks API, from which we just got a proper RESTful response, we should now get a 401, an HTTP 401 return code, because we're no longer authorized, because we're not supplying an API key. So here we go. And indeed, we can see that we get a 401 unauthorized. We're not providing an API key to access our API product, our tracks microservice, and we are no longer authorized to interact with our the API of our microservice. And note that later in this demo, we will generate the API key that will grant us access to the API again. Now we've deployed our tracks API or API product using a route table, but we haven't defined the developer portal yet. We can deploy the basic portal definition via the dev portal YAML file, which we can see here. And that dev portal YAML file uses labels to define which API product should be exposed via this developer portal. And in this case, that label is portal dev portal, which can also be found on the tracks API RT, so the route table for tracks API, which is our API product. And we can see that the same label is defined here. So this means that our developer portal will expose our tracks API product. In other words, the portal does not statically define which APIs get exposed, but performs a dynamic selection using labels. Now let's deploy this developer portal to our Kubernetes cluster. So we can deploy the dev portal by saying k apply -f dev portal YAML, and it creates the portal. So we can now check that deployment. We can see that it's being deployed in the Gloo Mesh add-ons namespace. So we'll take a closer look at that deployment, and we can see that the status is set to accepted. The portal automatically creates a portal config from the existing API doc resources. These are the API docs that are referenced by our API products, so through our route tables that we have configured in the dev portal to be exposed. So we can take a look at that as well. So we say k get portal config -a, and we can see that a portal config for this developer portal has been created. So let's take a closer look at that config. So it's created in the Gloo Mesh namespace, and we say get portal config developer portal, the entire name of the deployment -YAML, and we can see here that it has pulled in the API doc for our tracks API. So here's the tracks route table, and it's got the metadata here included as well. Now from this API doc, the portal actually creates a stitched API. So it combines multiple API docs from all the API products that are exposed through a given route table in a stitched API doc. So let's take a look at that. So we can say k-n glue mesh get API doc, and this is the stitched API, as we can see here. So that's the API schema. It's the same one, and we can say that we want to check the YAML file of that, and here indeed we can see inlined the stitched API, open API specification of our tracks REST API. We can now also curl the REST API definition from the developer portal REST API. So let's try to do that. And you can see here that we're doing a curl on the developer.example.com, which is the REST API over developer portal, the portal server, and then we'll check the schema of our tracks API product. So we'll execute that, and indeed we get back the open API specification of our tracks API product through the developer portal. We can also fetch a list of all the APIs exposed via the developer portal, and we can do that using the following curl command. So we say developer.example.com/portal server/v1 and then APIs, and that will give us back a list of all the API products that are exposed via this developer portal. In our case, currently we're only exposing the tracks API product, so that's the only one that's returned. But if you deploy multiple, all the APIs that are available via the dev portal will be returned. Our example developer portal UI is deployed as a node-based service in our cluster. And to access the developer portal UI, we can go to developer.example.com. So let's try that, developer.example.com. And indeed, here is our developer portal UI node application. So we can go to view APIs. And indeed, we can see that our tracks API, our Catstranos REST API is deployed here. So we can view all the APIs that have been exposed via our developer portal and to which we have access. We will add authentication and authorization flows later in this demo. So if you don't have authorization for a certain API, you will not be able to see it. So if we click here on this API, we can see the API documentation, the open API specification of this particular API product. We can now deploy another API in this microservice environment. So we're going to deploy the pets API. And like with the tracks API, the pets API YAML definition deploys the Kubernetes deployment and service. So let's give that a go. So we're going to say k apply, and we're going to apply both the deployment and the service, as you can see here. The API has not been exposed yet through a route table, so let's do a quick port forward to see if we can access it. So we port forward into the pets REST API service on port 5000, like so. And then we go into a browser and we're going to say localhost 5000 Swagger JSON. And as you can see, the pet store API and microservice have been deployed and are accessible using port forwarding. So if everything is correct, then there should now also be an API doc generated for the pets REST API, which you can see here. So we have now 3 API docs, one for the tracks API, one for the pets API, and the stitched API doc that we saw earlier. And this becomes important when you have multiple APIs in a single product. With the pets API and service deployed, we can now add the required route table to the platform, which defines the pet store API product. So we say k apply -f pet store route table. And to make the pet store API product accessible to the outside world, we also need to connect it to the top level domain. So we can do that in the api.example.com route table, which we can see here. And you can see here that for a URI with the prefix pet store, we want to delegate that to the route table with the label API pet store, which is exactly the route table that we have just deployed. So this label matches the label that you see here. So let's uncomment this section, search, save, and now we can apply or reapply this route table. And if everything is correct, we should now be able to go back to our dev portal, and we go back to the APIs, and indeed we can see that our pet store REST API has now been deployed. So we can go into the specification and we can see the available RESTful resources here. Now we can now deploy two additional APIs, the user API and the store API. And like with the other APIs, these are implemented as individual microservices as well. So we will add these APIs to our pet store API product, but first we need to deploy the APIs and services. So we go back to the command line and we say k apply -f APIs, and we're first going to deploy the users API, and we're going to deploy the store API, like so. So we've got those two APIs deployed, and now we can add these two services to the pet store route table. So let's go back to the pet store route table that we just opened here, and here we can see that there is a users API which forwards to the users REST API service on port 5000, and this is for the same for the store API, so everything with a prefix /store goes to the store REST API. So we can uncomment this to include them in our pet store API product. We reapply that route table, and now we can go back to the developer portal, and you can see that automatically the store microservice and the user microservice and its APIs have now been added to our pet store API product here. To use our APIs, we will need to create API keys so we can authenticate with our service and our APIs. Remember that we had secured our Tracks REST API earlier, where we got the 401 unauthorized, so we will need an API key to authenticate and be able to access that service again. Now in Gloo Portal, API keys are bound to usage plans, and a usage plan defines a policy or set of policies that define the usage of the service. And one of the most common examples is rate limiting. Now, to create an API key, we first need to be authenticated to the portal. So we click on the login button here, and we provide our username and password to Keycloak, which is our identity provider. And now we can see that we're logged in as user 1. When we now look at the API keys, we can see that we can still see the two API products that we have deployed, the Catstronauts and the Pet Store API, but there are no usage plans available yet. And that's because we have not enabled the usage plans in our dev portal yet. So if you look at the dev portal YAML file, we can see a section here called usage plans with 3 plans, bronze, silver, and gold, but they have been commented out, so not yet enabled. So let's first enable those usage plans. So we uncomment that section, save the file, and then we apply that YAML file. And we go back to our portal and refresh. And there's still no usage plans here. And the reason for that is because we have not defined any rate limiting policies for our API products yet. And the way we do that is through a rate limiting policy file here. So that this rate limiting policy file defines the usage plans for our service, and it states that it applies to all routes that have a label usage plans dev portal. And if we go to our Tracks API here, we see that our Tracks API route table actually has that same label. So when we apply this rate limit policy, it will apply to our Tracks API product. So let's apply that policy, rate limiting policy, and when we go back to our dev portal UI, we refresh, and we can see that there are now 3 plans defined here for our Catstronauts REST API. We have seen that without being logged into the dev portal UI, we could see all the APIs that were available on the portal. Now, there can be situations in which you want your public APIs to be seen by any user, whether they're logged into the portal or not, and other private APIs to be shielded from users that are not authenticated to the portal. And in that case, we can set an API to private and only allow access to certain users. So let's log out of the portal here, and we can go to view APIs, and we can see that we can see both APIs here. Now, there is an option in the dev portal configuration that states private API labels. Portal visibility, private. This means that any API product or route table that has the label portal visibility private is now marked as a private API and will require a user to be authenticated to be able to access it. Now let's look at our Catstronauts API, and we can see here the label portal visibility is private. Let's uncomment that. So when we now reapply this route table configuration, this API product will be marked as private and will require the user to be authenticated and have access to that specific API. So let's reapply the tracks API route table or API product. And when we now go back to our dev portal UI, we can see that the Catstronauts API is now private and no longer accessible by our user. Now let's log in and see if we can access the API when we are authenticated with the portal. And no, we're still not able to view that API, and the reason for that is that although we've authenticated with the portal, we have not yet been authorized to actually see this API. And that authorization is defined in portal groups. So a portal group defines the memberships, so based on the claim in your token, if you have a key, in this case the key group with the value of users, you will be part of this portal group configuration, and you will have access to all the APIs with the label API tracks. So in this case, this is this API product, and you will have access to the usage plans bronze, silver, and gold. So let's apply this portal group, and if everything is correct, our user 1 has a claim group users in its token, so it should belong to this portal group and have access to the tracks API again. So let's check that. Apply -f, and we want to apply the portal group. And when we now go back to the developer portal, we indeed can see that we have access again to the tracks API. And when we now go to the API key section, we can see that we have got access to the usage plans again. We can see our Catstronauts REST API again, but to be able to access our service based on the usage plan, we need to create an API key. And we can do that right here in the UI, and let's create an API key for the silver plan, which should give us 3 requests per minute. So we add a key, and we give it a name. It can be any name, so we call it my key. We say generate key. Now note that this API key will only be displayed once, so we'll copy that to the clipboard, and you need to copy that to a secure location. So let's create a new file here, and we've got our API key here, and now we can go back to our console, and let's try to access our service to see that it's still secured. So yes, we still get a 401 unauthorized. Now let's try to use our API key to access the service. So we say -h, so we say that we want to add a header to our request, and we want to call api.example.com/track API tracks. And now with the API key, we can see that we get the proper response again from our tracks API because we are authenticated and authorized. Now let's see the rate limiting policy in action. As said earlier, we've got 3 requests per minute based on this usage plan. We've done 1, so let's do another request. That's 2. A third one, and now when we try to access the API for the 4th time, we can see that the rate limiting policy kicks in with a 429 too many requests. So this was a brief overview of the Gloo Platform portal. I hope you've enjoyed this demo, and see you for the next one.